Kaspa vs Solana, the definitive Layer 1 comparison. A comprehensive analysis of two high-performance blockchains, their architectures, and upcoming upgrades. Executive Summary. Kaspa and Solana represent two fundamentally different approaches to building high-performance Layer 1 blockchains. Solana is a mature, monolithic proof-of-stake chain optimized for synchronous atomic composability and raw throughput today. Kaspa is an emerging proof-of-work block DAG network undergoing a transformative upgrade cycle that aims to deliver programmability, sub-second finality, and extreme block production rates while preserving sovereignty and decentralization. Let's start with Kaspa's four major upcoming upgrades. First, VProgs, or verifiable programs. These are Kaspa's native framework for scalable programmable applications. The yellow paper was published in September 2025. Each VProg is a sovereign application and independent, verifiable state machine. Execution happens off-chain, but correctness is proven using zero-knowledge proofs posted to Layer 1. This means Kaspa's base layer serves as a sequencer and data availability layer, but does not execute VProg logic itself. What makes VProgs truly unique is sovereignty. Each VProg exclusively owns its accounts and is solely responsible for state modifications. Each VProg defines its own gas model, fee structure, and resource constants. If one VProg fails, it cannot compromise another's liveness. This is fundamentally different from monolithic chains where all programs share a single execution environment. The VProgs MVP is planned for late 2026 to early 2027, with full synchronous composability targeted for 2027 and beyond. Second, DAGKnight Consensus. This is the next-generation consensus protocol that will supersede GhostDAG. DAGKnight achieves 50% Byzantine fault tolerance, the theoretical maximum for proof-of-work, compared to GhostDAG's 33%. Most importantly, DAGKnight is parameterless. It requires no assumed upper bound on network latency for safety guarantees. This means confirmation times adapt to actual network conditions rather than worst-case assumptions. A working prototype was confirmed in January 2026, with mainnet activation predicted for mid-2026. Third, 100 blocks per second. Kaspa completed the Crescendo hard fork in May 2025, increasing block production from 1 to 10 blocks per second, achieving 100 millisecond block times. The target is 100 blocks per second, which would mean 10 millisecond block times, the fastest of any blockchain. At the current 10 BPS, Kaspa has demonstrated a peak of 5,705 transactions per second and processed 158 million transactions in a single day. At 100 BPS, estimated capacity reaches 30,000 or more transactions per second. Fourth, Covenants++. These are programmable spending conditions on UTXOs, the foundation layer for VProgs. The covenant-centric hard fork is scheduled for May 5, 2026, bringing native KRC20 tokens, 20 or more new introspection opcodes, ZK verification opcodes via KIP16, the Silverscript programming language, and the groundwork for VProgs. Now, let's examine Solana's architecture and upgrades. Solana achieves its speed through 8 core innovations. Proof of history provides a cryptographic clock for verifiable ordering. Tower BFT is a modified consensus mechanism with exponential lockout voting. Gulfstream eliminates the traditional mempool. Turbine uses BitTorrent-style block propagation. Sea-Level enables parallel transaction execution. Cloudbreak provides memory-mapped account storage. Pipelining creates a 4-stage hardware pipeline. And all components are deeply integrated. Firedancer is Jump Crypto's ground-up C/C++ rewrite of the Solana validator client. It went live on mainnet December 12, 2025, after 3 years of development. In benchmark demonstrations, Firedancer achieved 1.1 million transactions per second for simple token transfers. More importantly, it introduces genuine client diversity before Firedancer, a single codebase controlled 70 to 92% of staked SOL. Alpenglow is Solana's upcoming consensus upgrade, approved in September 2025. It replaces Proof of History plus Tower BFT with 2 new protocols, Voter for 1 to 2 round finality, and Rotor for optimized block propagation. The target is 100 to 150 millisecond deterministic finality, faster than a Google search response time. Now, the head-to-head comparison across 7 dimensions. Dimension 1, Speed. Solana has a massive lead in real-world sustained throughput at 1,500 to 4,000 transactions per second, compared to Kaspa's approximately 10. However, Kaspa's block time is already faster at 100 milliseconds versus 400, and at 100 bps would reach just 10 milliseconds. Firedancer's 1.1 million TPS benchmark represents a completely different order of magnitude. Verdict: Solana leads today. Dimension 2, Finality. Both chains currently have similar finality times of about 10 to 13 seconds. Both target sub-second. Solana's Alpenglow at 100 to 150 milliseconds deterministic finality would be superior to DAGKnight's sub-second probabilistic finality for absolute settlement guarantees. However, DAGKnight's 50% fault tolerance means Kaspa can withstand more adversarial conditions. Verdict: Solana edges ahead on finality speed, but Kaspa has stronger security guarantees. Dimension 3, Decentralization. This is the most nuanced comparison. Solana's Nakamoto coefficient of 19 to 22 is significantly higher than Kaspa's approximately 2 at the mining pool level. However, Kaspa offers permissionless proof of work participation and a fair launch with no pre-mine. Solana's validator costs of $60,000 to $100,000 per year exclude home operators, and validator count has declined from 2,500 to roughly 900. Verdict: mixed, with different trade-offs. Dimension 4, Programmability. Solana dominates here with mature, production-ready smart contracts since 2020, a massive DeFi ecosystem, and 3,200 monthly active developers. Kaspa has no smart contracts yet. Covenants arrive May 2026, and full VProgs in 2027 or later. Verdict: Solana dominates. Dimension 5, Synchronous atomic composability. Solana provides this natively. A single transaction can invoke multiple programs atomically. This powers flash loans, multi-hop swaps, and complex DeFi strategies. Kaspa's VProgs design aims for composability while maintaining sovereignty, which would be architecturally novel, but full synchronous composability is the long-term target for 2027 and beyond. Verdict: Solana is proven, Kaspa is ambitious but undelivered. Dimension 6, Interoperability. Solana has mature cross-chain infrastructure via wormhole connecting 30 or more chains. Kaspa's interoperability is nascent with bridges still planned rather than deployed. Verdict: Solana leads significantly. Dimension 7, VProgs versus Solana programs, the most architecturally significant comparison. Solana chose composability. All programs share an execution environment, making DeFi composability trivial but meaning applications cannot independently control their liveness, throughput, or fees. Kaspa chose sovereignty. Each VProg controls its own execution, isolated from other applications' failures, but cross-application composability requires complex mechanisms. VProgs represents a novel paradigm that, if successful, would offer unique properties not available on any existing chain. The risk-reward profile differs dramatically. Solana offers certainty of current capability, Kaspa offers the potential for a fundamentally different future architecture. In conclusion, Solana wins on proven capability today, throughput, composability, ecosystem, and developer base. Kaspa's upcoming upgrades, VProgs, DAGKnight, 100 blocks per second, and Covenants represent a genuinely novel approach to blockchain architecture. The sovereignty model, ZK-verified execution, 50% fault tolerance, and parameterless consensus are all unique contributions. But most of Kaspa's programmability stack remains in development through 2026 and 2027. The honest assessment is this: Solana is where you build today. Kaspa is a bet on a potentially superior architecture tomorrow. Both chains face their own challenges, and both deserve watching closely. This report was compiled from 88 unique sources on February 14, 2026. Thank you for listening.